Alright guys, I'm doing this with my phone because the SD card ran out in my GoPro. I yak so much. We just turned over 305 miles on the dash, which is really about 325 miles. Our low fuel warning light came on, so we'll get gas at the next station. And the reason isn't so much that I don't think we can go further, it's that I don't want that fuel pump running in air. Meaning when your fuel tank goes below about an eighth of a tank, the fuel pump becomes exposed to air, and that fuel pump is fuel cooled, so I don't like running them low. One little trick, the miles per gallon readout is down to 36 miles. When it gets below that, it'll say low fuel or something like that, and that's a warning, your second warning that you're going to run out of gas. Now we got a ways to go before our next gas station, so we're just going to keep cruising along here, and when we get to the gas station, we'll do the math on what our mileage was. But I'm really happy that we got well over 300 miles before the low warning indicator came on. Alright guys, there's not a gas station in sight. We just kicked into the low fuel. I think we went about 20-30 miles since the last check. I did come down this grade, which the vehicle stayed in 4-cylinder mode most of the time, and that definitely helped. I'll tell you, a 500 horsepower vehicle isn't very fast if you have to push it. So I did the math, and we've gone about 338 miles so far. We've got another 20 miles and still no gas stations in sight. Ironically, I'm listening to a telephone line, which I might need in the near future. Alright guys, I think we're safe. We're going downhill. We're in AFM. As predicted, it is raining. We're going to stop here and get gas, and then I'll fill you in on what the economy of this thing was. But it looks like we're going to get about 350 miles on this tank. And by the way, we still have a little bit left on this gauge. It's not pinned. We got about a notch left. So again, I could probably keep going, but I don't want to. We're going to go here and get a burger and some gas. Alright guys, pump shut off. Here's what we used. 19.505 gallons. So let's go in and do some math. It's cold out here. Alright, we're back in our warm Jeep. I don't know how those cows take it. I did the math and we're 5% off. So we actually went 347.76 miles, which we'll round it up to 350 miles, I think. And you can see that our on-dash display is pretty accurate. It says 303 miles to empty. Now I put 19.5 gallons in it, which means we had 2.5 to 3 gallons left. So we're going to take this divided by the 19.5 miles or gallons that we used, and it's 17.83, so almost 18 miles to the gallon. Guys, you know, in this Jeep, considering the conditions that we had to go through, getting close to 18 miles to the gallon to me is fabulous. I get guys calling me all the time telling me they're getting 9 to 10 miles to the gallon, 11 to 13 miles to the gallon. Gee, the Great Salt Lake is a lot smaller than I thought. Oh, there's the Great Salt Lake in front of me. Actually, back in the 80s, I used to come out to the Salt Flats. I worked with a guy named Tony Ruthven. He was an ex-Navy SEAL or UDT, and he worked for the Southern California Timing Association, the SCTA, who held events at the Salt Flats. Tony actually built some of the fastest motorcycles in the world, the world's fastest Harley. I don't know if it still holds the record, but it was over 300 miles an hour back in that day. It was built by a guy named Andy Hansen. That was a really nice guy. He's no longer with us. Back in that day, you pretty much lived by duct tape and a hammer. And to go 300 miles an hour, I remember talking to Andy. He was a big man. Let's just say he weighed a lot, and he tried to ride, drive that Harley. And he was telling me, up to about 150, 180 miles an hour, you turn left and you go left. And above 200 miles an hour, you turn left and you go right because of the gyroscopic precession of the front tire or rear wheel. I don't know what it was. All right, guys, we came to Salt Lake, drove around a little bit, and it's time to leave. We're at 421 miles, which is really about 450. because the odometer's off. We're gonna just red ball it back to Las Vegas. We're gonna run the speed limit, which is about 80 miles an hour. I'm not gonna make any attempt to save gas. I'm just gonna drive it normal and at the speed limit. I do believe the weather is pretty crappy up there. We had some rain while I was here. So we're bombing along right now at 80 miles an hour in the 80 mile an hour zone. And the LT seems to handle it differently than other powertrains. At the bottom of a hill with most powertrains, you'll downshift. The engine will start revving up and you go up the hill. The LT doesn't really do that. What you'll feel is it'll kick out of 4-cylinder mode and you'll feel this extra torque kick in. I'm not sure if it's the torque converter clutch unlocking or it could be the camshaft phasing, but you just get this extra torque and it pulls you up over the mountain. Zero drama. The RPM pretty much stays about 2,000 in this vehicle, as you can see, and you go over the hill. So on this tank of gas, we've gone about 190 miles. We've got between half and 3/4 of a tank. This tank has been mixed highway and street driving. We drove around in Salt Lake for a while, and we're going to cruise at 80 miles an hour. So it's going to be interesting to see how this tank compares to the last tank. The last tank we got about almost 18 miles to the gallon, just over 17. Now that was with some rain and bad weather. We really haven't had any bad weather on this trip so far. It's been cold and it rained a little this morning, but otherwise it's been pretty nice. All right, we've been cruising along here at about 80 miles an hour for a while. I said earlier I would talk about the O2 sensors and feedback, and now is a good time. If you look down here, as stated previously, the voltage is your control module voltage. We're running almost 14 volts, that's good. Look at our long-term fuel trims. Those are an extremely important parameter. We're going to talk about that. You can see that we're running stoichiometric 14.7 to 1. You'll notice that the O2 sensors are a little bit scratchy because we're going in and out of 4-cylinder. We're actually a 4-cylinder right now at 80 miles an hour, which is interesting. And you're seeing them flatline a little bit down, and that's because we're going into deceleration fuel cutoff. The downstream O2s are going to be flat like that. They're monitoring the after cat exhaust, and they're just looking at the O2 level essentially, because most of the hydrocarbons and CO have been removed at this point. So you notice we just dropped into 7th, going up some of these steeper grades, but it'll kick back into 8th and kind of go between. All right, so let's look at these long-term fuel trims. 1.56% and 3.12%. Long-term fuel trims are basically the culmination of everything. Now in the Chrysler operating systems, they run what's called speed density. So they're using engine RPM, intake manifold vacuum, and maybe coolant temp to control the fuel delivery. It is a simple setup and it does not run an airflow meter. The LTs and most of the GM operating systems do run an airflow meter. In a perfect world, if you were running perfect gasoline and the air temperature was perfect and there were no environmental changes, both altitude, you were at sea level, and temperature, like we're running in the 40s right now, then those long-term fuel trims should remain pretty much close to zero. Now you saw that 102 flatline a little rich. That means we're starting to go into performance enrichment because we're going up this steep grade. As soon as we flatten out, you can see it starts switching. It's going to start switching again. Now look at that long-term fuel trim at 0. That's where we want to see it in a perfect world. But here's the reality. Some guys live in Florida at sea level and it's 100 degrees. Other guys live at the top of a mountain in Colorado and it's 32 degrees. So these operating systems have to deal with all that. So we have short-term and long-term trims. If you put some bad gas in, like I just left Utah, and the gas up here is pretty low quality. If I go back down into Vegas, the gas is going to be a different quality. Also, the temperatures in Vegas are a lot warmer than they are here. So something has to take that up with a mass airflow system. The mass airflow sensor measures the air going into the engine. And the operating system knows with X amount of air coming in to the engine running at a specific RPM, the coolant temp being at a specific temperature. In this particular engine, we have a humidity sensor, so we know the moisture content in the air. It knows approximately what the fuel delivery should be. And if it's not that, and it has to add fuel, or pull fuel out to get it to run at stoichiometric. What that means is, right now we're adding 1.56%, which is really not that much, to make this engine run at stoichiometric, which is 14.7 to 1. And that's why those O2 sensors are switching. Above 450 millivolts is rich, below 450 millivolts is lean. So it's trimming the fuel delivery. Now in the old days we had things called block learns. And block learns, basically each cell was programmed for a value. So as you drove it, it would learn what that value is, and then it would just kind of use that. The LTs don't run that way. The LTs are coefficient based, so they make all these decisions on the fly, and that's why these computers are so complex. It's a coefficient based system. So it's taking things into account. Are you in four-wheel drive? What's the temperature? What's your speed? What is the intake manifold pressure? And it just adds all these things up, multiplies them on the fly, and gives you fuel delivery. This is more accurate, and in my opinion, you're not going to be able to beat the mass airflow system. The speed density systems do have their advantages. They are simpler, there's fewer components, and they're easier to tune. That's why guys like them on the track. But there's nothing like a mass airflow system when it's working right. I mentioned in previous videos when GM dropped the mass airflow sensors on the tune port engines, they lost my favor. The throttle response, the mileage, it all just dropped. And I know why they did it. It was expensive back in that day, the precious metals, the MAF burn-off relays. But the LTs have taken it to a new level. If you think of the complexity of this engine, it's nothing like an LS and it's nothing like a Hemi. This engine has got not only a mass airflow sensor, so it's not running speed density, but it's also got a humidity sensor. It's running an 8-gear transmission. We could be running a 10-gear transmission. It's got continuous variable valve timing where the cam is moving all the time. It's got direct injection, so the pulses of that injection are constantly being changed. It's got a 4-cylinder mode, so it takes this 8-cylinder into a 4-cylinder, and then all those calculations have to be redone. And the end result is just amazing. It means you can take your heavy JK and get relatively good economy and still have close to 500 horsepower performance. Now there's just no getting around physics in a petrol engine. It's going to have to use X amount of gas to do what it has to do. How efficient can you make that engine is what matters, and over the last 20 years we've made huge strides. From the turn of the century up to about the 70s, the engine's got a little bit more efficient, but really not that much. In the 70s, they choked those motors down with emissions, smog equipment. By the late 80s, it became apparent that we didn't have to sacrifice performance and mileage for emissions. So in the early 90s, you started seeing a lot of fuel injection systems pop up, sequential fuel injection systems, higher compression engines with combustion chambers designed for pump fuel. And by the late 90s, we had some pretty cool stuff. I remember in the mid-90s, the lean burn engines were running 30 to 40, maybe 50 miles to the gallon on some of them. I ran them in the tune ports, and it was pretty amazing. It's a pretty big bird there. So yeah, we're going up a hill again. We downshifted. Now it'd be interesting to see if those O2s flatline rich, and they are a little bit. In a LS or a Hemi, I can tell you right now, those O2s would be flatlined like a rooftop, because it'd be putting a lot of fuel in the engine. I mean, we're going up a relatively steep grade at 80 miles an hour in a brick, but we are staying closed loop, and you can tell because not only is our fuel trims staying stable, but look at the air-fuel ratio. We're staying at 14.7. I don't think I've gone into open loop in this entire trip. Now, it's always something, guys. We're fighting wind, and now it's starting to rain. So I don't really care. I just want to see what kind of economy we're going to get if we push this thing. We're going to maintain 80 miles an hour. We're going to run through this weather. We're going to get gas here in a bit, and then I'll give you the numbers. So I want you to understand how important the long-term fuel trims are, because if you ever call me and say, hey, my engine seems to be running lean, it seems to be running rich, whatever, the first thing I'm going to ask you is there any codes, and what are your long-term fuel trims at? Now here's a couple of tips. If those trims are opposite, like one's plus 10 and one's minus 10, you probably have an O2 sensor backwards. If those trims are close to 0, but switching like these are right now, you can see I'm moving a little bit above 0, constantly staying about plus 2%. That's perfect. That's exactly where you want to be. But if they stay 0 all the time, that could be indicative that you're in speed density. If the system senses a failure in the MAF circuitry or the MAF sensor itself, it will ignore it and revert to the map sensor. So it'll run pure speed density, and those trims will stay at 0. So if you see your engine's running good and you want to look at your long field trims and they're always at 0, there's something wrong. And that's pretty amazing that this engine is pulling up this hill, staying in closed loop. And now we're going to be going down the hill, so just any second now. There you go, we're a 4-cylinder. So what you want to do is monitor your long-term fuel trims, and if they're not where they need to be, there's a couple of things that could be happening. One, you could have your MAF calibration off. When GM designs an engine and they put it in a chassis, they run it. The air intake, the restrictions in the bends, and the size of the tubing and the volume all come into play, and then they tune that calibration for that setup. If you completely change that intake and put a free-flowing intake system on with a K&N filter, those values might change. If you make modifications to the engine like a camshaft, or you put a snorkel on, that could change the MAF calibration. So one would be the calibration. Two would be you have a mechanical problem. It could be an air leak, there could be a seal leaking, you could have a fuel pump with low pressure, or you could have a regulator that blew out and you have high pressure. But the point is if your fuel trims aren't running where they need to be, then you got a problem. Don't accept that. You got to figure out what the issue is. And I'm sure a lot of you are saying, just throw the MAF away and make it run speed density, which you can do in these operating systems. But I can only tell you from my experience in the last 20-30 years of doing this, that a properly running MAF system is excellent. In fact, we've been going up and down in altitude, and I've noticed 0 difference in the way this engine runs. If you're running speed density and you don't have a baro sensor, the baro sensor is basically measuring atmospheric. Then as you go up and down in altitude, the computer doesn't have a baro reference. So if you go too high up in altitude, say over 4,000 to 5,000 feet from the key on point, then you may want to stop, shut the motor down, and key back on, let it sit there for a few seconds so it can get a baro reading, because it uses the map sensor for a baro reading when you key up, and then start it up and you should be good to go again. Pentastar suffered from that. That's not going to happen in this LT, because this LT not only has a mass airflow sensor, but it has a humidity sensor, and as you can see, it's raining right now, so that humidity sensor is definitely going to come into play. And we got some really strong side winds here. Alright guys, so things have kind of gone from bad to worse. We're in a rainstorm, and I'm not really sure how that's going to affect the economy, but it can't be a positive thing. So we're going to drop our speed down. We're going, I don't know, about 70, 75 right now. There's a lot of water on the road. We want a hydroplane. Ironically, I'm still going into a 4-cylinder mode. You know guys, this is where it really pays off. We got a Wrangler JL back there that's been blowing by us on the downhills, but on the uphills I just got the cruise set at 80 and he just fades away. Here we are at the gas station filling up. We're in Utah, and my experience is they have pretty low grade fuel. Now they have 91, which we're putting in this engine, and you can probably get away with mid-grade on the L86. This is an L86 we're driving, not an LT1. I probably wouldn't run on an 85, but I have run the L86s on regular gas when you're not under a load, you're at low altitude, not towing a trailer, and they seem to run fine. I do believe GM says it's okay, but I notice if you put higher grade fuel in, the octane scalars go up and you get better mileage. So we're going to put premium in this one. All right, so we took 14.2 gallons, and let's do the math on that. All right guys, I hope you can follow with the math here. We're at 545.2 miles. Now we know that's off by 5%. It's reading low by 5%. We filled up at 311 miles. So here's what we're going to do. We're going to take the 545 miles minus the 311 from the original tank, and that's going to equal 234, and we're going to multiply that by 1.05 to add back the mileage that we lost on the inaccuracies, and that equals 245.7, and we're going to divide that by the 14.2 that we just put into it, and look at that, we're at 17.3. So we dropped about 0.6 of a mile per gallon, but if you consider we just came through that storm and we cruise at 80 miles an hour. That's really respectable. Now, some of you guys are going to say, hey, you know, I've got a 10-speed LT Tahoe and I get 21 to 23 miles to the gallon, and that's true. I did a swap for a dealership owner here, and he has a 19 Tahoe 10-speed with a 6.2, and he gets 21 to 23 miles per gallon on trips. But he's running 31-inch tires. He's not running the drivetrain drag. He doesn't have the aerodynamic drag. When you add it all up, the JK is really a brick. It's an aerodynamic brick from the days past. Now the JL is better, but still not that much. We're just north of Cedar City. We've been cruising at 80 miles an hour now for close to 2 hours. I wanted to add that going 80 miles an hour in a heavy four-wheel drive Jeep may or may not be a good thing. I get customers calling me, telling me they've been over 100, one guy 140, and you have to consider your suspension and your tires. A 40-inch tire at 100 miles an hour is a pretty dangerous thing. This Jeep has smaller tires and weighs a little bit less, so it's been really comfortable cruising at 80 miles an hour. But if you're on 1-tons and 40s and you're running low tire pressure, it's probably not a good idea to do that. Another concern I see with a lot of these Jeeps is death wobble. You could be on the highway for an hour and you hit a bump just right and it throws it into death wobble. And this doesn't even have to be worn out parts. I've seen brand new suspension setups do it. So if your suspension is set up right and it's tight and your tires are rated for the speed, then by all means go the speed limit. But a lot of the Jeeps that I've got in my shop, I can tell you I would not cruise for hour on end at 80 miles an hour. We're just north of St. George, so we're going to drop out of our 80 mile an hour zone. We've been going 80 for about 3 hours, I'm going to say. I haven't backed off. We've pretty much kept the speed limit, except where it was raining very heavily. If you look behind us, we're out of that now, and things have cleared up going to Vegas. We've gone 150-ish miles, I'm going to say, since fill up, and we've used just over a quarter of a tank. So it definitely looks like we're using more fuel this tank than the previous tanks, but I haven't backed off. We've maintained our momentum. I think what I'll do, we're clearly going to get back to Vegas before I run out of gas, so I think what I'll do is get back to Vegas, do some street driving with it, mix that in, and then we'll get a reading on the mileage with both highway and city. So I said I would mention Logandale on the way back. This is Overton, Logandale, and there is some awesome wheeling out there. It's really becoming like a mini Moab, and it's an excellent place to wheel. Anything you want to do, rock, sand, it's all there. At the same time, if you go to Overton, go out next to Lake Mead, because that road basically goes out to Lake Mead. They have a museum out there for the Native Americans, and there was a town out there called St. Thomas, and St. Thomas was one of the towns that was flooded when they built Hoover Dam and created Lake Mead. A couple of years ago, because the water level in Lake Mead dropped so far, some of the foundations of the buildings could be seen in St. Thomas, and a lot of tourists went out there to see that. A lot of the experts said Lake Mead wouldn't rise again, but this year I think it has. We've got a lot of precipitation, and I think I was told that the level had risen. The water company here did one of the largest projects in Lake Mead to get water from it. Because the levels were dropping, the intakes for water that powered our city was not going to be underwater much longer. So they did a underground tunneling project and drilled into the bottom of the lake, and Google that. It's a really interesting project. Now, we've been on the road for over 800 miles. You can see the temperature here in Vegas is a lot warmer than it was up in Salt Lake, and the altitude is also different. So that just goes to show you that having the operating system that has all these additional inputs like humidity sensors and airflow meters can be an advantage. This Jeep has not missed a beat. I haven't opened the hood the entire trip. We've filled it up 3 times in the 800 miles. I'll easily make it home. So there is a somewhat hazy Las Vegas. We are back. I must say that that view is a lot better at night. We have gone about 850 miles. The low fuel warning light just came on. I don't know how many miles we've gone since the last fill up, but I'm going to do the math. I do think that we got less economy on this last leg because I pushed it, as you can tell by all these bugs. We were cruising at 80 miles an hour most of the way. We also did street driving and we went through bad weather. So we'll see what the end result is of this last leg. I'll put that up, but the LT definitely made the trip nice. If I was in a V6, the trip would have been not nice. So we'll come back with the final clip and give you the numbers here soon. We're on the final leg of our journey. The dash is reading 825.4 miles. I don't know what the last fill up was, so I'm going to have to do the math after I look at the previous video. But here's how much gas we're going to take. The low warning light came on back on the freeway. I've done some city driving since then. Now this tank holds, I believe, about 22, 23 gallons. So we're pretty close.